Have you ever wondered where our moon, the mysterious nightly companion of the Earth, came from? Our moon, a beacon of intrigue and marvel, holds an importance that transcends the boundaries of our world. Its elusive presence in the night sky has often led to questions about its origin, igniting great debates among scientists. These debates, filled with fascinating theories and speculations, are yet to reach a consensus. So what is the story behind our moon's birth? Today we delve into the captivating theories about the moon's origin. The first theory we explore is the fission theory. Now, this is a fascinating concept that suggests the moon was once a part of our very own Earth before it spun off into the cosmos. Picture Earth spinning so rapidly on its axis that a chunk of it was flung out into space, eventually becoming the moon we know and love. This idea isn't as far-fetched as it sounds, and it was actually proposed in the late 19th century by George Darwin. Yes, that's right, the son of the legendary Charles Darwin, who gave us the theory of evolution. However, as captivating as the fission theory may be, it's not without its flaws. For one, the Earth's spin at the time would have had to be incredibly fast to create enough centrifugal force. And then there's the issue of lunar samples not quite matching up with Earth's composition. While intriguing, the fission theory has its drawbacks, leading scientists to propose other theories. Next, we encounter the capture theory. This proposition suggests an intriguing tale of cosmic capture. It postulates that our moon was not born alongside the Earth, but was formed somewhere else in the vast expanse of our galaxy and was later ensnared by Earth's gravitational pull. Imagine, if you will, a rogue moon wandering the cosmos until it strayed too close to our planet and was irrevocably drawn into orbit. The idea is certainly compelling, a narrative fit for a science fiction novel. However, this theory struggles to account for certain facts. One significant hurdle is the strikingly similar composition of the Earth and the Moon. For the capture theory to hold water, we would expect the Moon to have a distinct alien composition, reflective of its origins in a far-off corner of the galaxy. The capture theory, while fascinating, also faced criticism, paving the way for yet another theory. Then comes the co-formation theory, a proposition that suggests an elegant ballet of cosmic proportions. It claims that the Earth and Moon were born together, side by side, from the very same solar nebula. A nebula, for those unfamiliar, is a vast cloud of dust and gas, the raw materials from which stars and planets are made. So imagine this: Earth and Moon, siblings in space, coalescing from the same swirling mass of cosmic matter. It's a picturesque notion, isn't it? However, as elegant as it may sound, this theory isn't without its flaws. For one, it doesn't quite explain the difference in core compositions between the Earth and Moon, nor does it account for the angular momentum of the Earth-Moon system. These discrepancies, these unanswered questions, have led many a scientist to look elsewhere for answers, and so as we move forward, we find ourselves with the most widely accepted theory. Finally, we reach the giant impact hypothesis. This theory proposes a celestial drama of epic proportions. Picture this: over 4.5 billion years ago, a rogue body about the size of Mars, often referred to as Theia, careened into the young Earth. The collision was so intense that it hurled substantial amounts of debris from both Earth and Theia into the space around our planet. Under the powerful influence of gravity, this hot, molten debris began to coalesce, and over time formed the celestial body we now know as the Moon. This dramatic hypothesis has gained considerable acceptance because it explains several unique properties of the Moon. For instance, the Moon's composition closely mirrors that of the Earth's mantle, suggesting a common origin. Moreover, the giant impact hypothesis explains the Moon's size in relation to Earth, its unusually small iron core, and the angular momentum of the Earth-Moon system. It also accounts for the Moon's lack of volatile substances, which would have been vaporized in the heat of the collision. Yet despite its compelling nature, the giant impact hypothesis isn't without its challenges. Some argue that the chances of such a perfect collision happening are incredibly slim. Others point to certain lunar samples that don't entirely align with the theory. So while the giant impact hypothesis stands as the most accepted theory, the enigma of the Moon's origin remains. So how did our Moon come to be? A question that has intrigued mankind for centuries, and one that we've tried to answer through various theories. Let's take a moment to revisit these theories briefly. First, we have the fission theory, suggesting that the moon was once a part of Earth, spun off into space due to our planet's rapid rotation. Then there's the capture theory, proposing that the moon, formed elsewhere in the cosmos, was pulled into Earth's gravitational grip during a close encounter. Next comes the co-formation theory, which posits that the Earth and the moon coalesced side by side from the primordial disk of gas and dust that surrounded the young sun. And lastly, we have the giant impact hypothesis, the most widely accepted theory today. It suggests that a Mars-sized body, often referred to as Theia, collided with the early Earth, leading to the creation of our moon from the resulting debris. However, as compelling as these theories are, none of them perfectly explain all aspects of the moon's origin. There are still unanswered questions and inconsistencies. For instance, why does the moon's composition closely resemble Earth's mantle and not a mix of Theia and Earth as the giant impact hypothesis would predict? Why is the moon's orbit not perfectly aligned with Earth's equator if it was once part of our planet, as the fission theory suggests? These lingering questions remind us that the moon's origin remains one of space's great mysteries, a puzzle that scientists and space enthusiasts alike continue to unravel piece by piece. The enigma of the moon's origin continues to captivate us. As we gaze upon the moon, we are reminded of the vast mysteries that our universe holds. As we strive to understand more, we must appreciate the journey of discovery, knowing that with each answer a new question arises, propelling us further into the cosmos' infinite mysteries. Before we wrap up, I'd like to extend an invitation for you to join our community of space enthusiasts. If you found this video interesting, consider subscribing to our channel. We regularly bring you fascinating content about the universe and its countless mysteries. We'd also love to hear your thoughts on the moon's origin. Which theory do you find the most plausible, or do you have a theory of your own? Let us know in the comments below. And if you know anyone else who shares this curiosity about the cosmos, feel free to share this video with them. Let's continue exploring the infinite together. Thank you for watching. Stay curious.